the Triomf channel in Slack as well for asking any questions. So I'm pretty interested, by this talk. I know, handling secrets is very complicated, and doing it wrong, can have, tremendous, consequences, for an organization. So I can't wait, to see what you brought us today, Artëm. So the floor is yours.
Cool. Thanks very much, Alejandro. So this is Attacking Secrets in Cloud-Based Applications. Hi, everybody. My name is Artëm Tsvetkov. I'm a security engineer at Skyscanner, and this is my second time at BSides. Happy to be here again. I've been spending the last 20 years almost of my life hacking to learn. It never gets old. I do freelance security audits. I have certifications and hobbies, and then software-defined radio is a really cool thing that I've been getting into lately. Today, the agenda looks like this. First, I want to discuss secrets, what they look like and what they are. Then we'll take the journey to the cloud, and finally see how we can attack and defend secrets. So for the purposes of this, a secret will be defined as a piece of confidential information that is used for programmatic access. So for instance, if you have login credentials to an email account, right, and you just use them through the browser, that's not programmatic. But if you were to write a script and put those credentials in the script, then that means you're using it in a programmatic way, and so would fall in scope of this. Plain text secret, that term refers to the unencrypted initial form of the secret itself. So if you had a base64 encoded password string, right, you would say that you obtained a plain text secret by base64 decoding that string. A hard-coded secret refers to the fact that the plain text secret is written down directly in a file. Cloud is managed infrastructure with a shared ownership model. So it's like a huge data center that you're responsible for some stuff, but the cloud provider is responsible for some other stuff. Decoupling is a very important concept that comes into play when we talk about the cloud. It's not specifically new, but it's definitely a central theme. And what it refers to is the separation of a single system into operationally independent components, and we'll see how that plays out throughout the entire presentation. Infrastructure as code is a sort of relatively new thing that came in with the cloud, and machine readable files used for configuring the cloud. And so think of it as like a config file that you submit to your provider, and that config file tells the provider how to deploy the infrastructure, what resources it needs, and so on. And then roles and policies, again, not something new, but made an appearance in a big way in the cloud, because these are now the abstractions that you as the client or as the user define to specify authentication and authorization controls. And finally, the pipeline, once again, not something new, refers to an automated sequence of steps for building, testing, and deploying applications. And when we talk about the cloud, it's pretty much a basic concept, because you want to be able to deploy your code in a repeatable and automated way. Now, so the journey looks approximately like this. We start off with one host per application. This was a little bit back in the day, where you have your PHP code with Apache server and MySQL running all in the same place. You FTP your files over there, right? And your service will, of course, be on port 80. Everything hard-coded in code and config files, and that was all fine. So then that sort of shifted into separating the early signs of decoupling, so to speak, having one host with your web server, then having another host with your database server. That quickly sort of shifted into using containers, because, of course, having multiple hosts is very expensive. So you'd have just the one host, but with isolated containers, which could be linked together and networked together and interoperable. And this was good. And then sort of scaling that, we saw data centers, which were the big places with people who would be managing hardware and, the network behind this hardware, linking it all together. And you could rent some space in there and deploy your application there. But the problem was that the scaling was manual. If you had a lot of traffic and your resource, you weren't handling it well, you needed to go in and make some decisions, provision more resources to handle that traffic. On the other hand, if you have a lot of resources and then you have very little traffic, effectively you're paying a lot for an infrastructure that you're not using. And so that's not good. And the cloud emerged out of that. And apart from just managing the hardware, the cloud was now managing the hardware and some of the software. And it provided some really cool features like auto scaling, because Docker wasn't built to scale. And cloud providers, they designed these solutions that allowed you to scale it. I think this was a real game changer overall. There was, a secret manager as a product. So there was all these different products that you could use, and there was this infrastructure scope syntax that you could use to define which resources you needed. And of course, roles and policies made an appearance because that's, they're the links between the different components and define how they should interoperate. And then finally, that, today we see Kubernetes as a really big thing, trending. And so one way to look at it is Kubernetes, first of all, it's open source and has all these built-in features. It's no longer a provider like features you pay for or products you pay for. It's already built in. Kubernetes already knows how to handle auto scaling, auto balancing. It knows how to roll back things. It can do software updates at scale. It has a secret manager, and this is all built in. Like, all you have to do is just define that you want to use it and how you want to use it. And what that leads into the tendencies, application centric. What that means is that we're trying to get developers to write code and not worry about the infrastructure or setting it up or managing. All they have to do now is just provide this additional configuration file, infrastructure as code, that tells the cloud provider or Kubernetes what resources are needed to support the application, the code itself. And when we zoom in on that, the applications themselves, the application code and how it works, is also decoupled into several components. And typically there are three of them, one of them being the view, which is generally like the front end. It could be, graphical, it could be programmatic. This is what your users sort of see and access. And then you have controllers, which is like the back end. And this is your business logic. It knows how to handle requests. It knows how to handle data, what to do with it, and so on. And then there's data, which could be a database, could be a cache, but it provides some sort of model, a structured model for data that the application expects to use and manipulate. And then another dimension that I want to make a point about is secrets. And I think this is another dimension that can be completely decoupled from applications. And it's important because really secrets are they're always associated with identity and with some permissions. And this is a security area. And for the purposes of this presentation, I'm going to be using this icon to indicate a secret. Now I couldn't really find a good icon to indicate a secret. So I use this one to indicate that the moment you disclose some secret information, your heart skips a beat. So, yeah. And what you can see from here is that really there will be secrets always associated with connections between the decoupled components. And so they're like sort of a glue or a necessary part of a glue that keeps everything ticking together. And we'll see how that plays out. Now, to get all of that deployed into the cloud, as I mentioned, we use a pipeline. Pipeline is a series of automated steps. And this here indicates that the process is continuous. It means that developers keep on writing code, pipeline keeps on doing stuff with the code, and then feeding back some information to the developer, whether it succeeded, whether it failed, whether it was able to deploy, and so on. And this process can keep on going. It's repeatable and automated. And the general sort of steps that happen first is downloading the code. Once the code repository receives some code, it will use something like a webhook to notify the pipeline that there's new code. The pipeline will use a token to access the repository to pull the code, download it, and then it will install requirements. And this can involve using internal package repositories. And to use them, you will always need some kind of token or secret to access that. Then testing. Generally, the testing phase consists of linting, which refers to code style. So it's like think about single quotes versus double quotes, how many spaces for a tab, and so on, things like these. Unit tests, they refer to testing the application code function by function. And then finally, you can also add a security test. And here you can throw in your automation tooling. And as you will see, it's very useful. And at Skyscanner, we have worked on this problem, and towards the end, we'll see what things you could use for this. So then if the tests went well, the pipeline will start building the application image. And when it builds it, it will publish it into an image repository, which again, it will use some kind of secret or a policy associated with accessing that image repository. And finally, deploy the infrastructure. And so it will use, once again, some kind of secret to send to the cloud provider the infrastructure as code configuration that will reference this newly published image. And so the cloud will deploy all of that. And then the pipeline will be sending notifications back to the developer, again, some kind of webhook probably to let the developer know what's going on. Just to give you an example, a pipeline configuration is just like a file. It can be one or maybe multiple files per project, per code repository, but generally they're still in the code repository. Here, this one here is from GitHub Actions. In steps, you can see the steps that I was describing, installing, linting, and so on. They are sequential, so they always wait for the previous step to finish before starting the next one. And here at the end, this step needs a couple of secrets. And what you can see here is that the pipeline exposes these secrets as environment variables and through these secret placeholders. So it's not the real secret, it's just like a username for a secret. And this moment right here is key to decoupling secrets from the application code. And we'll see how that plays out. To put it all together end to end, this is the diagram. There's a lot of information on it, so just work through it with me. Right here in the middle, we have the pipeline as I was just describing it. Then here on the left, we have the developers that are going to be writing some code, and they're going to be using some kind of token to send that code to the repository. And then we saw what the pipeline will do. And so once it deploys the app, the application itself in the backend may have multiple secrets for accessing databases, external service providers, some kind of integrations, what have you. In addition, the graphical user interface may have multiple secrets if you're using client-side widgets like a map or a customer service or some kind of contact bot. They will all probably use some kind of token, and this token, even though it's obviously public, being in the GUI, it still needs to be restricted. Now, your users, they're going to be accessing the application through the graphical interface, and again, they can authenticate themselves in the system using some kind of secret, username and password, typically. And then you might also have some kind of client services that are consuming data from you or pushing data to you, and they will also use some kind of token to authenticate in that. And so in all of this, you can see that there's a lot of secrets. It's not something specifically new, but you can see how they have multiplied and spread all over. And they have different purposes, different scopes, and different types. And there's different ways to attack all of this to gain an advantage and to hack the application. And so the general areas of attack, there's three of them, the first one being the repository. And to attack it, we can attack developers through social engineering, malware infection, or sometimes people unintentionally disclose their secrets. And so using OSINT, potentially an attacker can recover that and then use a developer secret to read or write to a private code repository. Having that, of course, you can exfiltrate information and potentially execute supply chain attacks. We'll see how that works in a later slide. In addition, you can also do code injection through compromised automation tooling. So today, more often than not, in a repository, there will be some kind of bot or integration that's going to be checking the request, maybe notifying people, perhaps commenting with a cool GIF. All of these are third-party things, applications, right? And they're writing inside your code repository. And so naturally, they may have access to secrets or just code in general. And here, a key point to make is that if a developer writes code that has hard-coded secrets, these hard-coded secrets are exposed directly in the code repository, as well as everything that goes further down the line, the pipeline and the runtime in the cloud. If the credentials are hard-coded, they remain hard-coded throughout. Stealing the webhook, for example, if you have in your pipeline configuration file, as we saw, if you have it hard-coded in there to notify you, so the attacker could read that file, get the webhook, and potentially continue on triggering builds, denying you sort of from building your own services, because your build host will always be building something. Now, when we look at defending that, first line of defense is due diligence, which refers to evaluating what third-party integrations you're bringing in. Do security assessment questionnaires, which is asking the providers how they handle security, how they manage data. Do your own security audit, reality versus expectation kind of thing. Check it. Minimal privileges is a big one, restricting scope of the secrets. So if your one developer token is able to access all the repositories, read them and write to them, that's very different from stealing a token that might only have a specific repository in its access. Oops. Use unique expirable tokens so that you can identify, in case of a leak, you can identify who was affected, how, and so on. Using unique webhooks for triggering builds, so a sort of functional segmentation, right? If you have one webhook that the attacker has, and now the attacker can build any repository with that hook, it might give a much bigger advantage. And finally, avoiding hard-coded secrets, as I mentioned, is a huge one, because avoiding them will prevent them showing up all throughout the pipeline. And avoiding them is mainly using these placeholders, as I already showed in the pipeline example. In code, you can also use things like these, environment variables. So your app expects the API key to be there. And when it starts running, it first checks that key and then does stuff with it. In this case, you're avoiding hard-coded API key in here. And if you have a config file, you can also use placeholders here. The format is, you can pick any format. I guess it will largely depend on whether your pipeline is capable of automatic substitution in these static files or not. If not, then what you can do is just write a simple shell script or Python script, what have you, that would substitute these variables for you, again, using something like this. Alternatively, if you don't want to use environment, you can use request to a secret service API, like a secret manager. You would request it with, for example, this key, and then the service would reply to you with a secret value, which again would avoid having the actual hard-coded secret value in there. Moving on to attacking the pipeline. The pipeline can be attacked through a supply chain attack. And so this attack might happen because of compromised packages or dependencies. And in addition, dependency confusion. It happens on this stage when the pipeline starts building the code and it's pulling some dependencies that it needs to install so that the app can run. And one really, really cool case was by this guy, Alex Bursan. He came up with this clever trick. So essentially what happened was, here you had some, in this case, some PayPal project that had some dependencies. And these right here highlighted in red, these were private things, right? They had them in their own internal repository and they weren't in the public NPM. And so what Alex did was he just basically published public NPM package CPP logger version 1. And then all this pipeline tooling, the code repository tooling that bumps up your versions to keep your repository updated, it basically saw that there was a newer version of this and it pulled it from the public repository. And so here you can imagine that's like super mega critical because you're pulling code right directly into your pipeline. And
just to mention that we're going to have around 5 more minutes, for the presentation.
Okay, hurrying up. To make things worse, the pipeline normally runs as root, so you're having arbitrary code as root running in there. Overriding pipeline configuration, if possible, is another attack vector, which would allow you to maybe leak secrets from the pipeline. And injection additionally can be done through pull requests. And there was another case with Travis CI where they had masking of pipeline secrets, but then something happened and this bug was disclosing secrets through injection of pull requests, through injecting environment variables in a pull request. And so finally, common injection through compromised automation tooling, the same. If your pipeline in here uses any kind of Docker image or what have you, package that is not managed by you, it's third party. And if somebody compromises that, once again, it's very similar to a supply chain attack. Defending that, the first line is, once again, due diligence, making sure you know what is running in there. Hardening the build host. So if you can run it not as root, perfect, restricting network access. So so it can't access all the internet in the world. Locking dependency scope in your packages to make sure that when you download internal packages, they're actually downloaded from your internal repository. In NPM, you can scope them. Taking over registering in public repositories, registering the same names to prevent people from hijacking them in the way that Alex did. And of course, avoid using secrets and pull requests in general. Finally, attacking the application part here, all the same OWASP stuff still applies, in particular path traversal, like local file inclusion and remote code execution are nice because you can disclose hard-coded secrets and potentially with RCE call other endpoints to retrieve them. If you have unrestricted API keys, these can be abused. And SSRF, server-side request forgery, this thing made an appearance in a very big way in cloud. Because of all these decoupled components, you can abuse the trust between the two components. There's Capital One breach example. What happened was that there was a role with all these permissions for accessing all over the place. And there was a bucket, an S3 bucket with sensitive information. So the bucket was protected, the role was protected. And then there was this person who had access to the role. And the trust between the role and the bucket was absolute because it was supposed to be like an internal thing. And so the person was able to exploit that trust. And it says maybe a server-side request forgery. I don't think it exactly is a server-side request forgery, but the idea is there. It's the abuse of that internal trust. In AWS, there's an endpoint with metadata that you can call. So if an attacker can compromise your EC2 instance, for instance, they inject through the pipeline supply injection, and then they call this metadata endpoint that you can retrieve active instance credentials for your EC2. The defense for this, the typical stuff, do early design reviews and threat modeling of your application to understand all these different points, where your secrets are, what permissions they need, and what are the vulnerable points to contest security reviews. Use automation tooling, as I mentioned, in your pipeline, in security tests, run static code analysis, run static file analysis, and use secrets placeholders in your code to decouple secrets from the application. At Skyscanner, of course, we had the opportunity to look at all of these problems, and Whispers is one of these applications that I've been working on. It's a tool that you can use to detect static file credentials. And so the difference here is that static code analysis tools, they typically cover dynamic code, like Java, Python, what have you, but they don't cover XML or JSON files to look for credentials specifically. And so Whispers does that. And what you can do is you can put it in your pipeline for security testing, or you can set it up as a pre-commit hook to even prevent your developers from committing potentially sensitive information. It's expandable with rules and plugins, and it's for non-executable files, including EAC, which is making a big appearance, and it does like private keys, certificates, and so on. We have other security automation tooling. Recommended, check it out. cfripr is really cool. If you're using AWS CloudFormation, it will tell you if your roles and policies are correct, and this is a huge advantage because it's very difficult to understand it. And if you have this tool, I think of it as security linking for EAC. It's super helpful. Then we have Lambda Guard, which is for serverless infrastructure auditing, and certain secrets for hard-coded, for detecting hard-coded secrets in Java and JavaScript. But this one is sort of getting phased out because there's now other tools that are better and more efficient. Nevertheless, check them out. To summarize, different types of secrets: developers accessing code, build secrets accessing repositories, packages, components, runtime secrets accessing services and data. Different ways to provision secrets. One of them is hard coding them, which would be at coding time. Another way would be using environment variables, which would be better, and using a secret manager, which would also be better with placeholders. And in this way, we will decouple secrets from the application. There are many problems and questions that must not only be asked, but they also have to be answered around secret management. Where to store plain text secrets, how to share it, how to do offboarding, when people are leaving the company. What happens if secrets are stolen or lost? How do you rotate them? How do you keep track of all these random expirable secrets, minimal permissions? And in the end, what you have is you have many people using many types of secrets for many different purposes, and you can appreciate that this complexity goes way beyond, the password security requirements that revolve around this. Best practices.
I think we're a little bit, over time. So
okay. Well, this is pretty much it. Thanks very much for your time, and reach out to me if you have any questions you want to follow up on besides Slack or on my LinkedIn. And just to mention, we're hiring in security, so ping me up if you're interested. Thank you.
Brilliant. So I got a question, but I will drop that in the Slack channel, because of time constraints. But thank you so much, for participating in BSide Barcelona. As usual, we've seen your face a few times. You're always welcome, to come again. So thanks so much, for your presentation. I appreciate it.
Thank you. Thank you for your time.